Good morning students, all of you. Today we will start our next chapter, that is the alternating current. What is the alternating current? Already we have discussed the EMF produced by a rotating coil in a uniform magnetic field, and we have seen that the current induced in the coil I is equal to I naught sine of omega t. This sine form of current is known as the alternating current. Clear? And the magnitude and the direction of this current will change time to time. Yes, because omega t is the angle. When we change the angle omega t with the time, then the value of instantaneous current it you can write will be changed. So this type of current, when the magnitude and direction will change time to time, is known as alternating current. The simplest form of alternating current, it is equal to I naught sine omega t, or you can write I is equal to, or it is equal to I naught cos omega t. And the instantaneous value of the EMF, you can write E is equal to E naught sine of omega t, and E is equal to E naught cos of omega t. These are the two simplest form of the current and the EMF. Clear? Now this, what is the value of I naught and E naught? These two are the peak value of the current. If you plot this one, I am drawing the sine curve, IT, I versus t, then how it looks like? Just it looks like omega t is along this one, and if you take the instantaneous current it, then with the passage of time, the instantaneous value of the current, the waveform will be just like this. This is the waveform of the current. You can understand that when theta is equal to 0 degree, then current amplitude is 0. When theta is a pi by 2, the current amplitude is maximum. You can write I naught over here. Again, when in this point, when theta becomes pi, then again it becomes 0. When in this point the I naught, I becomes minus I naught, isn't it? Because this is the 270 degree, I think this is the pi by 2, and this is pi and 3 pi by 2. At 3 pi by 2, the instantaneous value of the current is minus I naught. So you can take the sine form and the cos form everywhere. Okay. Next, what is the average value of an AC over a full cycle? We will discuss. Clear? Average value of an AC. So average value of an AC over a full cycle, obviously over a full cycle. What is the average value? All of you know that the average value of the instantaneous current, how you have to take that IT, instantaneous current of the average value, is equal to, as we are taking the full cycle, IT is integration IT dt. But as we are taking the full cycle, so you have to take 0 to t, isn't it? Now average value of the full cycle, how will you get 1 by t integration 0 to t. Instantaneous value of the current, you can take any form, I naught sine omega t, I naught cos omega t, doesn't matter. I am taking the sine form, I naught sine of omega t and dt. Now if we integrate this one, then how it looks like? 1 by capital T, I naught is a constant, integration of sine t, sine omega t dt. Sine omega t is the cos omega t, sine omega t is the cos omega t minus cos omega t, and divided by what? Omega. What is the limit? Limit is from 0 to t, capital T. So 1 by t into I naught t omega I am taking, take it outside, then your limit will be changed. So limit cos omega t integration t to 0. Cos 0 is the 1 by t into omega, t into omega into I naught. Cos 0 is the 1 minus of t. If you put the t omega is equal to twice pi by t. So cos twice pi. What is the value cos twice pi? Cos n pi minus 1 whole to the power n from the 2 pi. So minus 1 whole to the power 2, that is the 1 plus 1. So you will get this one. So easily you can consider the value of the instantaneous current or average value of an AC over a full cycle will be 0. But you have to understand that over a full half cycle the value will be changed. Okay. So this is the average value of an AC over a full cycle. Similarly, you can calculate the average value of an AC over half cycle. Just you have to take the limit 0 to t by 2. 0 to t by 2, and obviously this time limit is t by 2, and you will get that value of average value of an AC over half cycle. Clear? Now come to the root mean square value or RMS value or the effective value of the AC. It is better to write effective value of AC. So write effective value of AC. What is the effective value of the AC? That is the r.m.s. It is the actual value or root mean square value of an AC. How you have to take r.m.s, root mean square value over a full cycle. So I am taking the root first over a full cycle. So 1 by t, obviously there, as we are taking the average value, okay, over a effective value, that is the average value you have to take. But as notice here, as the effective value is depends on the I square term of the current, as the power is a pure quantity, so power is equal to I square RT. So you have to take I square term. Okay, so 1 by t integration 0 to t I square t into dt. All of you understood this one? Root mean square. First of all you have to take square, then you have to take mean means divided by t, then you have to take root. In the reverse order if you take, to remember it is very easier for you. r.m.s is equal to root over of 1 by t integration 0 to t I square t dt. Then what you will get? Root over of 1 by t integration 0 to t I square t. I square means I naught square sin square omega t, I naught square sin square omega t into dt. So what you will get? Root over of 1 by t integration I square term, take it outside. If you take outside I naught square sin square omega t, what you can write? Sin square theta, 1 minus cos 2 theta by 2 you can write. So 1 minus cos 2 omega t by 2 into dt. So what you will get basically? Root over of I naught square by 2 half into dt. So you can take the common 2 over here. Obviously we have taken the common 2 and t will be there. Integration 0 to t 1 minus cos 2 omega t into dt. So what you will get basically? Root over of I naught square by 2t. This is the dt, integration of dt. So you will get t minus of cos omega t. Cos omega t is the sin omega t, sin 2 omega t. Here 2 omega t is given over there, divided by 2 omega. So and the limit is from 0 to capital T. Okay, so root over of I naught square by 2t, capital T will be here, minus sin omega t. What is the value? If you put the t over here, notice, if you put the t over here, then time period t is equal to twice pi by omega, isn't it? So the value is basically 0 over here, first term. But so what you will get actually? 1 by t, okay, integrate it, no problem. Upper limit, this is the upper limit, minus of lower limit, minus of time period 2. So this is the twice omega, sine of 2 omega into t, sine of 2 omega time period t is equal to twice pi by omega, omega cancelled, omega cancel. So this will be the 4 pi minus of 0. So what you will get, root over of I naught square, root over of I naught square by 2t. Okay, so t minus of 0 obviously was there, and 4 pi, what is the value of sine 4 pi? Can you write? Sine 4 pi by 2 omega, sine 4 pi, sine 2 pi is the 0, so this is the 0. So what you will get if you take outside, so you can easily understood this one, tt is the cancel, so you will get I naught by root 2. So r.m.s is equal to I naught by root 2. Okay, so this is the effective value of an AC over a full cycle. Okay, that is the r.m.s. Now we will discuss the different current applied to a pure inductive circuit, resistive circuit, and what will be the hindrance offered by that type of circuit we will discuss. Okay, so first one is AC applied to a pure resistance. You can write AC containing only a resistance, containing only a resistor, AC containing only a resistor. So this is the resistive circuit. I am taking the circuit, and we have applied the AC source over here. What is the value of the AC? V is equal to V naught sine of omega t. Can you write? And this is the resistance R. Now this is the instantaneous value you can easily calculate from the V is equal to V naught sine omega t. But what will be the instantaneous current? We have to calculate. So from the conservation of energy we can easily calculate the value of the instantaneous current in this circuit. So right from the conservation of energy, conservation of energy, what you can write? Applied voltage V minus what is the applied potential, back potential you can consider, because when current entering to this side will take positive and this side is negative. So V minus of IR is equal to 0. I is what? I is the current, instantaneous current in the circuit. So IT you can write, or what is the value of V? V is equal to V naught sine of omega t is equal to IR. We are going to calculate the value of instantaneous current in the circuit. What is the value? I is equal to V naught by R sine of omega t. So V naught by R, can you write this one is the I naught sine of omega t. So notice here, it is the instantaneous current. I am taking the time IT. Okay, so applied voltage V is equal to V naught sine omega t, and we will get the current, instantaneous current IT is equal to I naught sine of omega t. Okay, so you can easily consider that for a pure resistive circuit the voltage and current will be in same phase. So how will you draw the phasor diagram? That is very important. What is the phasor diagram? Just you have to draw this one. This side is the phasor. So current and voltage and wave diagram also you can draw. This side I am drawing the phasor diagram, and this side I am drawing the wave diagram. What is the phasor diagram? Now the instantaneous voltage, you have to take the voltage over here, and the instantaneous current will be here. As there is along the same line, it is the rotating vector. So this is the V, this is the I. If you take the, and what is the angle? This angle is omega t. If you draw the wave diagram, then how it looks like? You have to follow this one. This is the maximum value V naught. This is the maximum value minus V naught. This is the maximum value for the I naught plus I naught obviously. This side is the maximum value is minus I naught. So from the wave diagram, V is equal to V naught sin omega t. So doesn't matter. V is equal to V naught sin omega t. Very easier for you. This is the wave. But if you see this, the IT is equal to I naught sin omega t, as they are in same phase, as no phase difference between there, V is equal to V naught sin omega t and I is equal to I naught sin omega t. So at a particular instant of time, current and voltage will be in same phase. So the phase difference is 0. So at the time of peak, here also the peak value of the current will be happen. At a current at 0, it is 0. This is the peak and this is coming to this one. So this will be the value as you see. So this side is the omega t. What will be the value? This is the pi by 2. This is the phi. This side will be pi plus pi by 2. 3 pi by 2. This side is the 2 pi and so on. So this side I have drawn the phasor diagram and this side is the wave diagram. And the hindrance offered by the resistance is a pure quantity. So the value of the resistance is R, and the omega t is the initial phase of the voltage, and from the equation of instantaneous current we can easily consider that the current and voltage are in same phase. Okay, but for an inductive circuit and resistive circuit it is totally difficult. Now let us consider an inductive circuit and we will discuss all these things over here. So give heading all of you, AC containing only an inductor. AC containing only an inductor. So AC containing inductive circuit, draw this diagram. This is the inductor. The symbol of inductor all of you know. Instantaneous value of the current, same voltage we will apply. L is the symbol of inductor. V is equal to what? V is equal to V naught sin of omega t, instantaneous voltage. Okay, this is the inductor current. Now you have to calculate the instantaneous value of the current. From the conservation of energy you can easily write. So write, from the conservation of energy, from the conservation of energy, what you can write? V minus back EMF produced by this inductor. What is the value? V minus L di by dt is equal to 0. Now from this current di, if you take the integration of this di, then you will get the instantaneous value of the current. So make subject di by dt. What is the value? I am writing L di by dt. I am taking in the left side, L di by dt, right side, is equal to V. V is what? V is equal to V naught sin of omega t. Or you can write di is equal to V naught by L. V naught by L into sin of omega t into dt. Okay. Now if you take the integration both sides, then you will get the value of the instantaneous current I. What is the instantaneous current? 0 to I, maximum current, and this is the time limit you have to take. Okay, or simply you will get a constant quantity, no need to take the limit, instantaneous current. At a particular instant of time you will get the value of the current. So what will be the value? di, integration di is the I, obviously it, instantaneous current, is equal to V naught by L sin omega t. Sin omega t is the cos omega t, but minus sign divided by omega. What is the limit? Limit is 0 to t, you can write. Okay, that t is obviously there, 0 to t, 0 to instantaneous at a particular instant of time, 0 to I. Initially the current was 0 and final the current is I. So what we will get is equal to V naught by omega L, it will be cos omega t, V naught by L omega or omega L. cos omega t, minus of cos omega t, minus of cos omega t. So minus of cos omega t, how it you can write v naught by omega L or L omega minus of cos omega t. Can you write sine of omega t minus of phi by 2? Can you write this form? Cos theta is equal to sine theta minus pi by 2 is equal to cos theta. That formula I have applied over here. So from this expression, what you can consider? Notice here, if we take this one, v naught by omega L or v naught by xl, omega L is a constant known as inductive reactance of this capacitor. I am writing xl where omega L is equal to xl is equal to inductive reactance. So if you take this one, what you will get? V naught by omega L is equal to I naught sine of omega t minus of phi by 2. So this is the instantaneous current. So what you can consider from this one? You can easily consider that the current in a pure inductive circuit, current lags the voltage by an angle phi by 2. So easily you can draw the phasor of this one. What will be the phasor diagram and how it looks like, I will show there. So any doubt over here? V is equal to V naught sin omega t and IT is equal to I naught sin omega t is equal to pi by 2. If IT is equal to I naught sin omega t, then there will be no phase difference. Phase difference is 0, which one happened in the case of pure resistive circuit. But in this case, for in pure inductive circuit, the current lags the voltage by an angle pi by 2. Lags the voltage by an angle pi by 2. Okay. IT is equal to I naught sin omega t minus of pi by 2. Now come to the phasor diagram and wave diagram. What will be the phasor diagram and wave diagram? I am drawing the phasor. This side the phasor and this side is the wave diagram. Okay. First of all, you have to take the V is equal to V naught sin omega t. So this is the V is equal to V, and you have to take the current amplitude I naught. I naught is lagging by pi by 2. So you have to, as the I naught is lagging, so you have to take I naught over here. This is the I. So this is the, what is the angle? The angle is pi by 2. As the current lags the voltage by an angle pi by 2. And if you draw the phasor diagram, then how it looks like? Notice it. The phasor diagram for this one, for the instantaneous value of the voltage, it will just like, this type of graph you will get. As it is a sine graph, so no problem. So this is the voltage. But for the instantaneous current, it will looks different. What it will look? Notice here, at omega t is equal to, notice from the expression, at omega t is equal to 0 degree, so the instantaneous value of the sine minus theta, so minus I naught will be the value. So it will starts from this point. It will starts from this point. In which point? This point. Okay. Then at pi by 2 it will become 0. This is the pi by 2. This is the pi by 2. It will become 0. At the phi, it will goes to this point. Okay. Again, at 3 pi by 2, it will become 0. At the 2 pi, it will again become maximum. Again it is become this. So this is the current amplitude. I think all of you understood this one. If you draw these diagrams, so you can easily dotted line. You can easily understand all these things. This is the V naught, this is the minus V naught, this is the I naught, this is the minus I naught. This is the minus. Okay. So these are the phasor diagram and wave diagram of the instantaneous current and voltage in a pure inductive circuit. Okay. So for the resistive circuit, what will be the value of the inductive reactance? R only. as resistance is a pure quantity, so its value is only R. For pure inductive circuit, the value of XL is what? Is equal to omega L, and the phase difference phi is what? Phi is equal to phi by 2. But in this case, the current lags the voltage by an angle pi by 2. Okay, that's why the wave diagram is just when current is maximum, current is 0, it is maximum. When current is maximum, it becomes 0. Again, when current is become 0, it will becomes maximum. Okay, so current and voltage are not in same phase. The phase difference between the current and voltage is pi by 2, and obviously the current lags the voltage by an angle pi by 2. Clear? So that's all for your today's class. In the next class, we will discuss about the capacitive circuit and the LCR series circuit. Thanks all.